Okay, we're going to tackle volumes of revolution in this video. So say we have the graph of y equals x squared, terribly drawn, but okay, so this is y, this is the x-axis as per usual, and as I say, this is y is equal to x squared. We can integrate this curve, we know that now, and if we integrate underneath between A and B, we can find the area under here, okay? But I'm just going to circle this in red. And then I'm going to draw on another little area. So we could also, we might be interested in this area here, but we're not interested in either of these two quantities for now. What I am interested in is today's topic, which is volumes of revolution. If we, this area here, if we rotated this round the x-axis, okay, we could find a volume. We'd get a shape. Okay, so if we rotated this all the way around, we would get a shape, and we might be thinking, what's the volume of that shape? Well, that volume, okay, would be equal to pi integrated from b to a y squared dx. Okay, so what we remember here is because we're rotating on the x-axis, we have a dx. Of course, y squared is some function of x, otherwise we can't integrate it. So we want y squared in terms of x, and b and a are these endpoints here. So if we rotate it, let's just complete this example. So this is equal to pi from b to a of y squared is x to the 4 dx. So this is equal to the integral from of pi x to the 5 over 5 from b to a, and this is equal to pi b to the 5 over 5 minus a to the 5 over 5. Okay, and that's equal to pi b to the 5 minus a to the 5 all over 5. Alright, so that's the volume if we rotate this shape round here. Rotate this region. What if we rotate this blue region around the y-axis? Okay, we're still defined by the curve y equal to x squared. Now we're bound by these limits here. So the formula for this volume, the blue volume, this is equal to pi d to c x squared with respect to y. So we're rotating around y, so we underline that here, and we are, this is quite nice because x squared is just equal to y, so this is just the integral of pi, well, pi times the integral of d to c of y with respect to y. That's just equal to pi y squared over 2 dc, and similar to before, we get pi d squared minus c squared over 2. Okay, and we could simplify that with the difference of two squares and all, but we won't bother. This is just to demonstrate the point. What is sometimes tough about these type of topics is they might actually, rather than asking you, here's this curve, if we rotate this round, what do we get? You might get asked, what's the volume of a cone where the length this and the length that, using volumes of revolution? And what you have to think about is, what sort of graph on the Cartesian plane can I draw such that when that's rotated around, it's going to give me the three-dimensional shape that they want to know the volume of in the question, and then formulating an integration from that. And that is the sort of thing we will look at in the next video on this topic, so the more problem solving aspect of this. Alright. Yeah, and it takes a little bit of practice to get the regions, but once you go to the regions and all that, and the integration is the standard integration you've been doing for the whole of your time at A-level maths. So if you do have any questions on this, what was covered in this video, let me know. If you think it might be covered in the next video, wait for that, and if it isn't, then you can let me know under that video. If you did enjoy, please be sure to like and subscribe, and I hope to see you in the next one.